All right, in this unit, we're going to study the topic of graph theory. This is a fairly new concept in the field of mathematics. It's only about 300 years old, which might not seem like that's young, but for mathematics, it actually is. A lot of the things that we study are thousands of years old. But in graph theory, we've got some basic terms that we need to know before we can proceed and make sure we understand what's going to be happening. So graph theory has its own set of vocabulary. And the first term that we're going to talk about is a graph. Okay, this is not a graph that you are used to seeing in like an algebra class, but a graph here consists of a finite set of points called vertices. That's these little things right here in this diagram, all labeled A, B, C, D, E, F, etc. And then the line segments that are called edges. And so all of these different pieces along here that are connecting, these are edges. Okay, and you can follow all those lines, including that guy right there. All right, a couple of things. A vertex is going to be represented by a dot, exactly as we saw over there at the side. And a vertex can represent a lot of things. It could represent an intersection of streets. It could represent a landmass like a city, Peoria, East Peoria, etc. It could be work, school, it could be people. It could be types of candy that you like. I mean, whatever. They are often, but not always, connected by edges. Okay. Now, please do look at the graph and pay attention to the fact that there are no vertices, for example, everywhere the lines intersect. There's not a vertex there, for example, in that spot that I just circled. There's also not a vertex over here. So just because lines intersect, it does not mean there's a vertex. There are lots of things that can happen. It could be like people who know each other, okay? It could mean person B and person F know each other, person D and person A know each other. That doesn't mean we've created a whole new person there in the middle that knows all four of them, okay? All right. The edges connect the pairs of vertices, and we've already gotten that term kind of talked about. And then there is a special edge, and that's the one up there at C and also at E. Those types of edges are called a loop, okay? And it connects a vertex to itself. And there are times when that is going to be appropriate. So using that little set of vocabulary there, vertex, edges, and loops, we're going to take the time now to draw some graphs that represent different scenarios. So in this first one, we've got a floor plan, and we're going to draw a graph where the vertices are the different rooms, or in the case of D, the area outside of the rooms on the graph. And then the doorways, so how you get from one place to a next, is going to be represented by an edge. So the first thing we need to do is put some vertices out there and label them A, B, C, D. It does not matter the order in which you do that. There's nothing special about it. And then we're going to start making some connections. So for example, right here, we have a doorway going from room A to room B. And so we're going to draw an edge that shows that happened. We also have a doorway going from room A to room C. And so we're going to draw an edge from A to C, showing that there's a doorway. There is an edge or a doorway from B to C. So we need to put that one in. We actually have two doorways going from A to the outside, from A to D. And so we need to put two edges in from A to D. We have one doorway going from B to the outside, which is region D. And we have two doorways, again, going from C to D. So that would be the graph that represents that particular situation. Each of the vertices represent each of the four rooms. And then every one of those lines, and they don't have to be straight, notice, okay? An edge is not necessarily straight in graph theory, but every edge represents a doorway. And so if you count up the number of edges, it should match 8, the number of edges in the doorway pictured, okay? All right, for the next one, there's a ferry service connecting islands together. We're going to draw a graph to represent the ferry service, and the dotted lines represent what's going on here. So my vertices are going to be my land masses. So Ira and Sallisaur, Kawika, I don't know how we really pronounce these, Zeola, and then over here, Holgerhaven. And so there is service from Ira to Sallisaur and to Kawika and to Zeola and to Holgerhaven. So we need connections from Ira to all 4 of those. Ira's now done. Sallisaur, notice, only has just the 1 to Ira, so that one's done. Kawika can go to Ira. We've got that line drawn in there. You can also go to Zeola and you can go to Holgerhaven. So now that one's done. From Zeola, you can go to Ira or Kawika. We've got both of those edges drawn in, but we don't have one yet to Holgerhaven. And then from Holgerhaven to Ira to Zeola and to Kawika. And again, we haven't missed any. So we've got that one that we can check off as well. All right, and last but not least, taking a look at some counties here in central Illinois. I am not even going to try very hard to make those quite in the same spot, other than to say I'm going to put Henry here, Bureau County, Putnam, Marshall, Woodford, Tazewell, Peoria. Guess I have to write out the P's since they're not single letters there. Knox over here, and I am going to stick Stark kind of out in the center. What I would like you to do is pause the video for a minute, draw in the lines that represent any connection or any counties that share a common border. So if they share a common border, they should have an edge between them. Again, take a second to pause the video and draw in your lines, and then come back and compare, see how you did. All right, welcome back. So take a minute, make sure you have all of the same edges drawn in. Now again, they don't have to be straight lines, they can be curved, it doesn't matter. It's not about how straight your lines look, it's about, do you have edges connecting all of the same vertices that I have, okay? And again, every edge represents a shared border between those counties.